All right, I'm going to work out just some of the problems that we worked out in class on Tuesday. These are from 3.3 where we're completing the square. So if you had trouble on any of these, just to help you out, so these are just some questions we worked out in class. So here we want to do this by completing the square. Remember, the first step is to move the constant to the other side. To t squared minus 8t, I'm going to leave a little space, and I have the 5 over there. Now, I'm going to come down below, and I'm going to bring down the t because it's going to go there. Now, the completing the square part, we always take half the middle coefficient. So half of a negative 8 is a negative 4, and I write it down below. So half of the middle coefficient, half of negative 8 is a negative 4. Now we're going to square that. Well, negative 4 squared is 16, so that's what we're going to add in here. The whole idea of completing the square is now we've turned this into a perfect trinomial square. That's what we're trying to do. So by taking half of negative 8, get negative 4 and square and 16. If you did this, you would get t minus 4 squared. Now, we can't just add a number to one side of an equation because it makes it out of balance. So to balance it out, if we had 16 on the left, we all need to also add 16 on the right. So now on the right, we have 21. Well, now we've created a square, so we can solve that by square rooting. If I take the square root of each side, the square root of that is just t minus 4. The square root of 21 is going to be plus or minus. We don't know any squares that go into 21, so that just has to stay the square root of 21. Then we want to get t by itself, so we add 4 to both sides. And there's our two answers. 4 plus radical 21, 4 minus square root of 21. All right, 48 is another completing the square. This one's a little different because here there was no number in front of the t. It's a lot easier when it's like that, when there's no coefficient of the t squared. Well, here there is one. So we have to do a couple of extra things. Now first, we're going to move the 1 to the other side just like we did before. Move the constant to the other side. Now, we don't want a coefficient of the x squared. So we're going to factor a 3, and we're going to factor out of both x's. So 3x squared divided by 3 is just x squared. 12x divided by 3 is 4x. And I'm going to leave a little space and close my parentheses. So we made it look like that. So we moved the constant. Since there was a leading coefficient of 3, we didn't want that in there, so we factored out of both x's. Okay? Now, to get ready for the next step, I'm going to bring down the 3 and I'm going to bring down an x because they're going to end up there anyway. Now we're ready for the completing the square. Just like we did before, half of 4 is 2. So I'm going to bring 2 down here. And then I square that. 2 squared is 4. That's what I need to add in here. So by adding 4 in here, this is equal to x plus 2 squared. We created a square by doing that. Okay. Now, everything inside these parentheses is multiplied by 3. So if we put a 4 in there, it's times 3. We actually added 12. Because 4 times 3 is 12. We actually added 12 to the left. Well, to balance that out, we need to add 12 to the right. 12 plus a negative 1 is 11. So we took half of 4 is 2. 2 squared is 4. Everything in the parentheses here is times 3, so that's really a plus 12. So to balance it, we added 12 to the other side. Now we've created a square again, so we want to isolate the squares. That means we divide by 3. Then we square root both sides. So we get x plus 2 equals plus or minus the square root of 11 thirds. Now we want to get x by itself. So we subtract 2, so x equals negative 2 plus or minus the square root of 11 thirds. Now that answer is okay. If they won't take that on Big Ideas Math, we need to rationalize this. Well, that's the same as negative 2 plus or minus. Remember, with a fraction, we can square root the top and square root the bottom. So that's the same thing. Now, if we don't want to square root in the bottom, we're going to multiply top and bottom by that square root. So now we have negative 2. Here, square root of 11 times the square root of 3 is the square root of 33. And here, square root of 3 times square root of 3 is the square root of 9, which we know is 3. So this answer is okay too. This may be what they want, big ideas not. So this answer and this answer we had here are actually the same thing. I guess this one here. So this answer and this answer are actually the same thing. Okay? So that's a couple of normal completing the square problems. Now the third one we're going to do is you also use the completing the square in some other things. Like if I want to graph this problem, if you remember when we were graphing, we put things in vertex form. Vertex form looks like this. F of x equals a times x minus h squared plus k. So notice we have a square in there. So that's why we want to complete the square. So that's what we're going to do here. We're going to make a little adjustment because this is a function. So here, I'm going to group the x's together. And I'm going to leave a little space. And this minus 1, normally we would move it to the other side. I'm going to leave it on this side. I'm just going to put it outside the parentheses. So it's the same thing. I just moved where it sits at. Now let's complete the square. So bring down the x. Half of negative 4 is a negative 2. Negative 2 squared is 4. That's what we add in here again. So we created a square here by doing that. Well, now we added 4 to the right. So normally we add 4 to the left. But because this is a function, we don't want to do anything to the left side. So instead of adding 4 on the left side, to balance out a plus 4 on the right, we're going to put a minus 4 on the right, which may seem kind of silly because we added 4 and we subtracted 4, but it's where we did it. We put the 4 in here to make this a square. To balance it, we put a minus 4 out here. It still is going to balance it out, but we put it out here. So now we have this. Well, that's our vertex form, because if we compare that to the original, that means h is 2 and k is negative 5. So that's our vertex. So that's how you use completing the square to put it in vertex form. So those are the ones we did in class. We should be, we did 3.4 today in class. Those were for 3.3. We worked on 3.4. Friday we'll be doing 3.5.